Let's talk about reference variables in C++ or references in C++. When we discuss normal variables, we discuss that normal variables create a label to a memory location. For example, this is our memory, a sequence of bytes, and we have a variable x. When we refer the variable x, we actually refer this memory. When we modify the variable x, the value at this memory is modified. When you create a reference variable, and if this reference is referring to x, it means now you have one more label for this memory y, right? Whatever changes you made to y, they are going to reflect to the same location, and x and y, they are now labeled for the same memory. How do we create reference variables? If you take a closer look at the declaration, we put an ampersand before y, right? This ampersand sign makes this variable y as a reference variable. So this is how we create a reference variable, and to show that when you make changes in the y, changes are reflected in the x, and when you make changes in the x, changes are reflected in the y. I have done this. I have first printed y. So y is same as x because they are labeled to the same memory now. So y is going to get u output 10. Now if I change x to x plus 5 and then print y, you are going to see y as 15. And now if I change y to y plus 5 and then print x, you are going to see x as 20 because they are labeled to the same memory. Let's now talk about some interesting points about references. When you create a reference variable, it must be initialized because a reference is going to be an alias to an existing thing, right? So x is an existing variable which is a label to a memory. You want to create an alias to the same thing, right? So it must be initialized. It must know for which it is an alias. Cannot be null. If you compare references with pointers, pointers is something that we are going to study. Pointers are also something which give you address of a memory location and give you access to the same location. But pointers are not considered safe in many situations because you can have uninitialized pointers. References have this advantage that they are safe because they are always initialized. The second thing is pointers can be null. You can have a pointer which is not referring to any valid memory location. But references are always created as an alias of an existing object. So they are not null. They are always referring to a valid memory location. Cannot be changed. Once you create a reference which is referring to a location or an existing object, you cannot bind this reference to some other location. Once it is referring to something, it is going to refer to that thing, right? That's the limitation of references. If you compare references in C++ with references in Java and other languages, this limitation is not there in other languages. This is only there in C++. And this is what makes references slightly limited. We can't use them in data structures like linked lists or trees. When we implement data structures, we have to use pointers when we are programming in C++. But in other languages like Java and Python, we use references for implementation of data structures. But in C++, this limitation and probably this limitation also cannot be null. These two limitations do not allow us to use references for implementations of data structures like linked list or tree. In those data structures, we have a sequence of items, and if we want to traverse them, we need to first refer to the first node, then the second node. So if you are using references, you can't change the references. But the pointer can change to any location, right? You have pointer currently pointing to one location. Later you can change it to some other location. So references are safer. They create an alias, but they are very limited.